Hello everyone, this is Charlie from IMAT Prep. I'm a medical doctor in Milan, Italy, and I've actually studied in the University of Milan. I took the IMAT exam back in 2015, and that year I came first in the exam. The following year, my brother took it, and he also got a top 10 mark. So we both studied medicine in Italy in the University of Milan, and currently we're both working full-time as doctors. Over the past few years, we have taught many students for the IMAT exam, and many of them got into medicine in Italy to become our future colleagues. So with this experience as students and also as teachers, my brother and I decided to form IMAT Prep, where we formed a complete IMAT course that aims to be the best one out there. We really believe in the power of what we've created, and that's why we wanted to give you a glimpse into the course. So enjoy it, and if you have any questions about the complete course, do not hesitate to send us an email at info@imatprep.com. So enjoy this segment of the course. We hope you get something valuable out of it. So this question is from 2019, and I'm pretty sure a lot of students will not have any idea about this question. So let's have a look at it. The diagrams show some pathways between the central nervous system and effector organs in a healthy human. Which pathway is a possible route for impulses passing along a parasympathetic neuron? So we have these options that include the brain, dorsal root, spinal cord, ventral root, ganglion, organ. So we have seen some of these terms. We have talked about brain, spinal cord. We have talked about dorsal root and ventral root. We obviously know what organs are, but we haven't really talked about ganglions. We came across it a few times, but we didn't go into detail. So this was on purpose because this final portion of the lesson is going to be dedicated on ganglions. So if you don't have any idea, that's completely okay because we haven't seen it yet, but we will try to explain what ganglions are, what type of ganglions we can find in the body, where they are found and whatnot, and try to come back to this question and try to attempt it again. I personally had no idea about ganglions when I was taking the IMAT exam back in the day. I learned about them in the university, but then again, there was no section dedicated to ganglions. So hopefully this final section will be helpful not only in the IMAT, but also in med school. So let's have a look. In order to understand ganglions, we first have to go back to these guys that we have seen. Let's do a brief recap of them. We said that there are different types of neurons, and we're going to recap 3 of them here. We said that pseudo-unipolar neurons had a very important role of carrying sensory information. These were called pseudo-unipolar because they look like they have only one long projection, but this is actually because this cell body got out of the way and the dendron and the axon ended up being on the same line. So different to the bipolar neurons that we had seen before, in which we had the cell body in the middle and dendron on one side, axon on the other, where the action potential had to go through the cell body. Here, the cell body moves out of the way, therefore we have an almost continuous axon and dendron, and the action potential bypasses the cell body. We have seen this before. We have also seen multipolar neurons, which had a very important role in transmitting motor information. So these were our motor neurons. These were called multipolar because they have multiple poles. So we have 1, 2, 3, 4, 5, 6 dendrons in this case, and 1 axons. So multipolar neurons, and the whole point of these neurons was to receive information from different sources, integrate it, and then give one output. So this could be, for example, an output telling the muscle move. We said that these were very important in motor neurons, but they are also very abundant in the central nervous system. So this is the most common type of neuron, and mostly when we labeled neurons and when we introduced neurons, we have talked about multipolar neurons. So they have many dendrites and only one axon. And then we had seen multipolar neurons again, but this time a demyelinated form of multipolar neurons. And we said that these were mainly found as relay neurons or interneurons. Again, this is a multipolar neuron because we have multiple inputs, but the axon is demyelinated. And we had mentioned that the myelinated portions were responsible for white matter, and the non-myelinated portions were responsible for gray matter. So when you look at the spinal cord or the brain and you see these areas of gray matter and white matter, you can understand where the axons are. So for example, we said these are sensory information going upwards, and where the cell bodies are. We can find cell bodies here, so we have synapses here. So let's come back to this reflex arc once more. We have seen it multiple times, but this is very important in introducing the concept of ganglions. So we said that we have a sensory neuron, which is a pseudo-unipolar neuron. You can see the cell body that got out of the way, the dendron and the axon that are almost continuous. And we have a synapse here with an interneuron, which is not myelinated, and another synapse here with a motor neuron with its cell body here. So all of this portion here is gray matter because we do not have myelin there. Then again, the motor neuron has its axon, which is again white matter. So in reflex arc, we talked about the pseudo-unipolar neuron, a multipolar neuron which is not myelinated, and a multipolar neuron that is myelinated. This is our motor neuron. The sensory information, we said, came into the spinal cord through the dorsal root. So this is the dorsal root bringing information to the dorsal horn of the spinal cord. Dorsal horn was the gray matter. We also said that the information from the ventral horn, this motor information, left from the ventral root. And again, these arrows are wrong. Apologies for that. But in the end, in the reflex arc, we had this unconscious reaction to the pain. So there was the pain, and from the spinal cord, this information went directly to the muscle and caused muscle contraction to withdraw the arm. So far, so good. Then remember that we had divided the nervous system into different parts. So central nervous system, peripheral nervous system, which divided into somatic nervous system, and autonomic nervous system, which divided into sympathetic and parasympathetic nervous system. And remember that these were motor branches, not sensory branches. So if we focus on the central nervous system, we talked about gray matter in the central nervous system in various contexts. We talked about the cerebral cortex, we talked about the cerebellar cortex, we talked about the spinal cord with this almost butterfly shape, which had the ventral horns and the dorsal horns. And we also saw some subcortical structures, including the thalamus, for example, that was made of gray matter. So in the central nervous system, you can basically categorize gray matter into cortex, whether it's cerebral or cerebellar, or nuclei, so things that are not part of the cortex, but nevertheless where we have synapses. So actually we have a lot of nuclei in the spinal cord. You can subdivide this gray matter in the spinal cord into its nuclei, and also you can subdivide these structures into their nuclei. For example, we mentioned that the thalamus was the relay station for sensory information. This is where sensory information stopped and synapsed before going to the primary somatosensory cortex. But even within the thalamus, we can find different types of nuclei. So the gray matter in the central nervous system is seen in the cortex or the nuclei, where we see synapses, where we see cell bodies. The gray matter in the peripheral nervous system, though, is found in the form of ganglions. So once we move outside of the spinal cord to go to the different parts of the body, we might still end up having portions where there are either synapses or cell bodies, and these are still gray matter. These are ganglions. So whenever you see ganglion, this is referring to what would have been gray matter, but in the peripheral nervous system. And we have 3 sets of ganglions in the peripheral nervous system. But the concept is the same. So in the central nervous system, we said that when we have white matter, we have myelin, and that is true. And where we have gray matter, we have the cell bodies and also synapses. And this is also true. And if ganglions are the counterparts of gray matter, but in the peripheral nervous system, then in the ganglions, we expect to find cell bodies again. So the concept is the same. What are these 3 sets of ganglions that we can find in the peripheral nervous system? These are sensory ganglions, sympathetic ganglions, and parasympathetic ganglions. Now let's try to understand these. First of all, let's start with sensory ganglions, because this is something that we have seen multiple times today in this lesson, but perhaps you might have overlooked it. We have seen a type of ganglion before. We have seen in this image many times the dorsal root ganglion. Why could this be the case? Because here we're looking at a pseudo-unipolar neuron, and the cell body is out of the way. And actually, if you imagine, there are many pseudo-unipolar neurons and a lot of cell bodies here that form a sort of gray matter here. So we form a ganglion outside of the central nervous system. This is a sort of grey matter, a ganglion, that is found in the peripheral nervous system. And look at its name. It is called the dorsal root ganglion. We have seen what the dorsal root is. Dorsal root was this entry point of this sensory nerve into the spinal cord. Dorsal because it's posteriorly found, sensory posterior. Root because the nerve is entering the spinal cord. In the case of the dorsal root, it's entering. In the case of the ventral root, it's exiting. But dorsal root. Ganglion, why? Because we have a cell body here. So this is the sensory ganglion. And actually, we have sensory ganglions throughout the spinal cord, because we have seen before that different parts of the body send information from different levels to the spinal cord. And actually, just before entering, because these are pseudo-unipolar neurons, we have the cell body right outside the spinal cord. So we can find the dorsal root ganglions next to and a little bit posteriorly, so a little bit behind the spinal cord, just as we have seen in this reflex arc image. So this is a dorsal root ganglion at this level, but we can find many of them at different levels of the spinal cord and on both sides. So all of these carry sensory information. And this type of sensory information can come from both visceral and somatic stimuli. In other words, these cells might have originated from the skin, for example, so somatic stimuli. Maybe it's carrying information that is pain from your hand, or it might be carrying some sensory information, so an input from an internal organ, viscera. So sensory ganglions carry both visceral and somatic stimuli. This is what I was referring to. This is showing us sensory information from the skin. So a sensory nerve from your forearm, for example, might follow this section and enter the spinal cord at the level of C6. So at the level of C6, we would find a dorsal root ganglion. So look at this image again. This is carrying information from the forearm. The dorsal root ganglion is at the level of C6, and this cut of the spinal cord is at the level of C6. But we can find other levels as well, depending on where the stimulus is coming from. Okay, so far so good for sensory ganglions. Sensory ganglions are dorsal root ganglions. Okay, let's move on to the sympathetic ganglions and parasympathetic ganglions. The sympathetic ganglions and the parasympathetic ganglions have nothing to do with sensory information, but they have to do with autonomic motor output. So we have talked about the sensory ganglions, so sensory from both the somatic and the autonomic divisions of the peripheral nervous system. But here, when we're talking about the sympathetic ganglions and the parasympathetic ganglions, we're talking about the autonomic and motor divisions. And this shouldn't come as a surprise, because we have divided the autonomic nervous system into sympathetic and parasympathetic, and we have mentioned that these two systems were actually motor systems. They weren't gathering information, but rather they were telling the body how to react in a certain situation. So these were antagonistic systems, remember, but they were motor systems. So here, these ganglions have to do with motor information. So if we're talking about motor, as we have said, this information has to go away from the central nervous system towards your target organ. And this is indeed the case in both sympathetic and parasympathetic systems. So let's take an example. The sympathetic nervous system tells the heart to beat faster. The parasympathetic nervous system tells the heart to beat slower. So these are both commands that have to go to the heart. Where does this command come from? It actually starts in the central nervous system, and here we are in the realm of the peripheral nervous system. Where exactly? In the autonomic part of the peripheral nervous system, because we're talking about the heart, and in the motor part of the peripheral nervous system, because we're talking about the information going away from the CNS towards the target organ. And in both of these cases, this is the architecture that we find. In both the sympathetic system and the parasympathetic system, we have a neuron that connects the central nervous system to the ganglion, and another neuron that connects the ganglion to the target organ, the heart, for example. The neuron that's before the ganglion is known as the preganglionic neuron, And the neuron that's found after the ganglion going to the target organ is known as the postganglionic neuron. This is the structure in both the sympathetic nervous system and the parasympathetic nervous system. Then if this is the similarity, what is the difference? Well, the difference is in the exit points of the central nervous system and also where the ganglia are found. So here we're looking at the central nervous system, so the spinal cord or the brainstem in this situation. We're looking at the ganglia and we're looking at the target organ, the heart. So remember that both sympathetic and parasympathetic systems will have two neurons, one going from the central nervous system to the ganglia and another going from the ganglia to the target organ. And this is exactly what we're going to see. When talking about the sympathetic nervous system, the preganglionic neuron has the cell body at the level of the thoracic or the lumbar spinal cord. So the cell body is here. It leaves the spinal cord at the thoracic or the lumbar level. In the case of the parasympathetic nervous system, again talking about the preganglionic neurons, the cell bodies are found either at the cranial level or at the sacral level, and the fibers exit from those levels. So the exit of these fibers are at different levels. The sympathetic ones exit from the thoracolumbar region, and the parasympathetic ones exit from the cranial or sacral regions. Then they go to their ganglia, but again, these ganglia are found at different regions. So the ganglia of the sympathetic nervous system are found near the spinal cord, so there is this connection here, and the ganglia of the parasympathetic nervous system are found near the target organ. So this preganglionic neuron has to go a longer way to reach its ganglia. And the same thing for this one. And in both of these cases, now these postganglionic neurons will have the cell body in the ganglia. Actually, this is why they are ganglia, because they have the cell bodies there, and the fibers go to the target organs. So let's have a look at them one by one. Let's start with the sympathetic nervous system. We can appreciate that there are two cells, the preganglionic neuron, the postganglionic neuron. We can also appreciate that the cell body of the preganglionic neuron is found in the thoracolumbar region of the spinal cord, and it exits there, and it goes to a ganglion that is found really close to the spinal cord. Then we have the cell body of the postganglionic neuron, and this is why we have a ganglion, because we have a cell body here, we have a non-myelinated portion of the cell here, therefore we cause this sort of gray matter outside of the central nervous system, which is called ganglion, and in this case a sympathetic ganglion, and this postganglionic neuron goes and reaches the target organ. And here we can see the representations of the sympathetic ganglions. Notice how they're still very close to the vertebra and the spinal cord. So these sympathetic fibers go to these ganglions. They actually exit from the ventral root and go to the ganglion. And notice how these are motor, so these are found more anteriorly. And remember the dorsal root ganglion, a sensory ganglion, it was found more posteriorly. So again, that generalization that we made of sensory being posterior, motor being anterior, works here as well. Here we can see two ganglions, the dorsal root ganglion, which is a sensory ganglion entering the spinal cord from the dorsal root going to the dorsal horn, and also a motor ganglion. Which type of motor ganglion? Autonomic, and more specifically, sympathetic, because it's very close to the spinal cord. Now let's have a look at the parasympathetic ganglions. Here is the parasympathetic ganglion. Again, we have two cells, the preganglionic neuron and the postganglionic neuron. The exit point is different, either cranial or sacral. The cell body is here, the exit point is here. We have a synapse in the ganglion. This is the so-called gray matter of the periphery. And in this case, we're talking about a parasympathetic ganglion that is close to the target organ. And here we have the cell body of the postganglionic neuron going to the target organ, the heart. And this is a representation of the parasympathetic pathway. Notice how there is nothing in the thoracolumbar region, but we either exit from the cranial portion or the sacral portion. This is exactly what we have said for the parasympathetic nervous system. And what's more, the ganglions are not close to the spinal cord, like in the case of sympathetic ganglions, or even in the case of dorsal root ganglions, which were sensory, but rather we find ganglions closer to the target organs. So this is exactly as we have seen. So reviewing everything together, we can see the sympathetic and the parasympathetic systems. Both of them are autonomic and motor, and both of them are made of two neurons, the preganglionic neuron and the postganglionic neuron. The cell bodies and the exit points of the preganglionic neurons differ in the sympathetic and the parasympathetic, and so do the locations of the ganglia. The sympathetic ganglia are closer to the spinal cord, the parasympathetic ganglia are closer to the target organ. So this is a representation that puts everything together. The parasympathetic fibers exit from the cranial or the sacral regions, whereas the sympathetic fibers exit from the thoracolumbar regions. And also notice that the sympathetic fiber have this sympathetic chain of ganglia, whereas the parasympathetic fibers have their ganglia closer to the target organs. So again, putting things together, sensory ganglions are made by pseudo-unipolar cells because they have their cell bodies a little bit out of the way. So these are found in the form of dorsal root ganglions, and these carry sensory information, both from the somatic nervous system and from the autonomic nervous system. And then we can find the sympathetic ganglions and the parasympathetic ganglions. Both of these are motor, and both of these are autonomic. And we have seen that both of these have preganglionic neuron and a postganglionic neuron. The exit points differ, and where these ganglions are found also differ. So this is a diagram that we had seen at the start of the lesson. This is the division of the peripheral nervous system, which divides into somatic nervous system and autonomic nervous system, which each divide into a sensory branch and a motor branch. So the sensory branch of the somatic nervous system was somatosensory, the motor branch was somatomotor, and we talked about the fact that sympathetic and parasympathetic pathways were both motor, whereas the sensory information came from general visceral afferents. And now let's try to place where these ganglions belong. So the sensory ganglions obviously carry sensory information, and they carry sensory information from both of these branches of the peripheral nervous system. So both of these divisions have sensory ganglions in the form of the dorsal root ganglions. What about the sympathetic ganglions? Sympathetic ganglions go to the motor division of the autonomic nervous system, and the parasympathetic ganglions go to the motor division of the autonomic nervous system as well. So we have this one left. So where is the cell body of motor neurons of the somatic nervous system? The cell bodies are actually found in the central nervous system, and we know this because we will come back to this idea of the reflex arc again and look at where this cell body of the somatic nervous system is. We know the somatic nervous system innervates muscle, and this reflex arc shows us that actually this fiber has its cell body in the central nervous system. Where specifically? In the spinal cord. Where in the spinal cord? In the ventral horn. And where does it exit from? It exits from the ventral root. So the cell body of a motor neuron that innervates the muscles is found in the central nervous system. The fiber exits from the ventral root, and this is a motor innervation. Going back to the ganglions, let's have a look at that. The sensory ganglions are made of pseudo-unipolar cells. So we have the ganglia that are really close to the spinal cord just as they are entering. And where do these fibers enter the spinal cord from? They use the dorsal root, and actually this is known as the dorsal root ganglion. The dorsal part of the spinal cord is more reserved to sensory information, whereas the ventral part, the anterior part, is more reserved to motor information, as we have seen here. But also, let's have a look at the other ones. The sympathetic system and the parasympathetic system have two cells in going from the central nervous system to the target organ, and there is a stop at the ganglion. So there is this synapse. We have seen these. But let's now try to understand where they get out from. Just like the other motor fibers, they get out from the ventral root again. So here, just as this somatic motor neuron exited from the ventral root, these autonomic motor neurons also exit from the ventral root, both the sympathetic ones and the parasympathetic ones. The sympathetic ones go to their ganglions that are very close to the spinal cord, and the parasympathetic ones go to their ganglions that are very close to the organs. Which organs? Viscera, so internal organs in the case of the autonomic nervous system, and in the case of the somatic nervous system, we have the muscles and the skin. So this is putting everything together. That said, let's go back to this question again and try to understand it. The diagram shows some pathways between the central nervous system and the effector organs in a healthy human. Which pathway is the possible route for impulses passing along a parasympathetic neuron? So let's have a look at the options. A says it comes directly from the brain, and we have this sort of pseudo-unipolar neuron, and it goes to the organ. This is not the case. Actually, we would expect to find two neurons in the case of a parasympathetic pathway. So this one is not the case, this one is also not the case, and this one is also not the case. So these are made of one neurons. Let's have a look at the options with two neurons. We see spinal cord, okay. Then we see a ventral root and a dorsal root. And we also see a pseudo-unipolar neuron here. This is weird because pseudo-unipolar is sensory, whereas the parasympathetic neuron has to be a motor neuron. But also, on top of that, the dorsal root is also wrong because the dorsal root is more reserved to sensory fibers and the ventral root uses the motor fibers. And what's more, here we're talking about parasympathetic. This ganglion is found very close to the spinal cord, whereas in the case of the parasympathetic nervous system, we would expect the ganglions closer to the target organ. So B is also not the option. Let's have a look at C. First of all, we see two neurons. So here is a preganglionic neuron and here is a postganglionic neuron. And they are not pseudo-unipolar like in this case here, so good. Let's also have a look at the exit point, ventral root. So this is also correct. Motor fibers exit from the ventral root. That's good. Ganglion, there is a synapse here at the ganglion. And where is this ganglion found? It is found very near the target organ. This is exactly right for the parasympathetic nervous system. So our answer should be C. And with that, we have concluded the nervous system. And next up, we are going to talk about the urinary system. So I'll see you there.